Finally, the bad guy is on stage. Aviation. And thanks, Matt from BT, for that kind introduction earlier. And be assured, I will remind our procurement people about it when they tender the next communication services contract. No, just kidding. Let me try to put a counterpoint to that. When I see this picture, I'm an aviation guy, I'm an airplane guy, my heart starts beating a little quicker. Because this is all about the emotion that mobility, and especially air mobility, brings to people. We are bringing people together, we are bringing cultures together. And I'm just returning from a meeting of the IATA, the International Air Transport Association. Their world meeting was yesterday, and one of the CEOs even talked about a peace effect that he sees from aviation, because when cultures come together, it is much more difficult to tell them that they should get at war with each other for whatever minor reasons. So it is a great industry to work in, and by the way, it also has quite an effect on the world economy, because 4% of the global GDP is expected to be supported by aviation. And for 1,000 extra passengers walking through Zurich Airport, one permanent job is created. So how comes that this great industry became so much under scrutiny in the last time? And of course, the truth is we have an effect on climate. We are emitting a lot of CO2. And we have a special effect because we're emitting the CO2 in high altitudes, 30,000 feet and higher in cruise flight. And this has special effects. They're called non-CO2 effects, or the RFI factors. And let me look with you a little bit why it is also that we have become so much, that we got so much attention, because we have no simple solution. This is what just was explained to you, being a hard-to-abate sector, because, and we're a little envious on automotive, for example, because for them it was a fairly easy thing, the electric car. And now if there are automotive guys here in the room, don't shout at me, I understand that also electrifying mobility on the ground is difficult. I can tell you it's even more difficult if you have to overcome gravity. So what did automotive do? They have the electric car, and everybody likes it. The governments like them, the regulators like them, the customers, and I think even the automotive companies start to like them. Now the bad news for aviation is there is no Tesla in aviation, or ID. Buzz, or what you like more as your electric car. Because electric aviation, it will exist. There are even the first flights on regional airliners on sale now that should happen in about 2 years. And an airliner from Scandinavia once told me it's a perfect aircraft, the electric aircraft, for northern Norway. Because it has a range of 200 kilometers and it's roughly 19 seats. And both is perfect for northern Norway because in most cases there's a fjord basically between two towns, and driving around it costs you hours, but the distance is very small. And as northern Norway is not so densely populated, 19 seats is pretty much a good amount. The big but is, this is not our business. It will be a niche that electric aviation plays into. So the real answer would be hydrogen. And hydrogen is under development. We hope for the first aircraft to be ready by 2035. Now these aircraft programs tend to be not on time. So let's be and expect it to last a bit longer. The big but is it is then one aircraft from one manufacturer, and you can understand that until this is a normal view on an airport near you, this will take time, and most likely we have not the time if we want to be carbon neutral by 2050. So not easy to decarbonize, because there's no alternative energy ready by now. What can you do? So, of course, the one thing you could do is to just lean back and hope the best. And that, of course, is not the thing that all the Swiss engineers that work here not far from us in the hangars of Swiss Airlines or in the headquarters would do, or any other of the ambitious people at Lufthansa Group. So we have decided instead set clear, defined, and also ambitious targets for us. And the main target is, in line with aviation industry worldwide, to be carbon neutral by 2050. What we have done as an on top is that we've independently validated the first steps of this decarbonization path by SBTi, the Science Based Targets Initiative. We were the first airline in Europe, the second worldwide, to have the validation of that decarbonization pathway done. And it means that we want to go down by more than 30% on the emissions per revenue ton kilometer by 2030. And this is a big step, a big first step for us, given all the limitations that we face and that we just discussed. What we also did is we've put in an interim target by 2030. We want to be minus 50% net CO2 already. And why did we do that? The reason is that we feel that waiting is not an option. We want to be part of the transformation of the industry, but also the surrounding technical solutions. And we want to support this transformation. That's why we've put in this interim target to remind ourselves to be part of that transformation. So, having targets, the big question is, how can aviation overall reach them? And this is a sample decarbonization pathway that we have, that is done by IATA, the International Air Transport Association. We're coming from 1.8 gigatons of emissions today, and you see the first solution we are going to do is technical, and behind technical in reality is fleet. Because by using the best available current technology, you can already reduce the emissions by roughly 20%. And that's, for example, why Lufthansa Group has more than 200 new aircraft on order to make sure that we can get the most out of these options or these abilities of the current technologies. You can also see on the far right side that liquid hydrogen and electric is already mentioned. It will have some effects on the technical side, but as they are only beginning, of course, they will be tiny. Not to be forgotten is the operational effects, because by using better flight planning methods, by getting the shortest possible distance to fly, by getting better climb and descent pathways from air traffic control, we can reduce our emissions a lot. It is expected that optimizing this only in Europe, where we have still a bit of a fragmented air traffic control system, we could save up to 10% of all the fuel emitted for European aviation. So this is a lot we can do. We need help of the regulators and, of course, politics for that. And we try to persuade them to basically lift that opportunity. But operational efficiency has one more effect. And that's about what we can do ourselves within our company. And it starts with weight. It is really very strict weight control. These items for in-flight service that for some reason are not used, but we are carrying them all the time, of course they have a tiny effect as the simple item, but given the amount of flights, it has a tremendous effect. So this is what we do a lot. Really checking and rechecking our loading lists, for example, and thinking what has to go on board. And there's one thing more, that is own technical ideas or developments. And one good example is the shark skin foil that was developed by engineers of Lufthansa Technik, together with BASF. And Swiss Airlines just completed the outfit of their complete 777 fleet with that foil. And as a shark skin, it is attached to the fuselage of the aircraft. It reduces the drag of air, and it saves roughly 1% of fuel, and of course with this also the same amount or the same percentage of CO2 emitted. So we can do a lot, we are doing a lot, but you also see all this, as the technical things are limited, will not do the trick. So what we are really needing for reduction is SAF, and SAF stands for Sustainable Aviation Fuels. And today they are existing, they are based on biogene residuals, and these biogene residuals, for example, use cooking oils, are transferred into aviation fuel, and they bring carbon into circularity. And with this, we are able not to emit new carbon. Now you can imagine, use cooking oils. I have 2 daughters. They're happy to go to McDonald's with me, but even if they would ruin all their health, it will not help aviation as a whole to decarbonize. So we need another type of SAF, the so-called power-to-liquid fuels. And these are synthetic crude oils built from green hydrogen and from carbon, and with the Fischer-Tropsch method, they are combined to a synthetic crude oil that can be refined together with the normal fossil fuels and then gradually replaces fossil fuels for our use. So all this is in the making, and we are actively supporting it. But what brings me here today on stage is the little, well, not so little, unfortunately, yellow column on the right. Because even doing all this by 2050, we expect to have residual fossil emissions of roughly 19% compared to 2019, as it is a hard to decarbonize industry. So, and these 19%, and there are several decarbonization pathways existing, so you will see everything between 15 and 20, but it is still a significant amount. This is what we need to accept as aviation. And for this, we need, of course, answers. And this is also what brought our Swiss colleagues in the lead, together with the Lufthansa Group, to the discussion with Climeworks. Because we need highly reliable, safe, and especially durable removals for a longer term. And direct air capture certainly is the premium solution for this. It is one of the negative emission technologies. Of course, we will look for more, but it is certainly the gold standard, if you want, for removals. It will be a crucial technology for us to make sure that we can meet our decarbonization pathways. It, by the way, has a second option, and I know that this industry is not following it so much, but as I said earlier, for the synthetic SAFs, we need carbon to come from somewhere. And so capturing it from the air can be, in the longer term, a good source to get that carbon from out of removals to produce these SAFs. As I said, not the focus today. We're happy with that. We let the industry develop. But in the longer term, we need that. So, carbon removal is important. For that reason, we said we cannot wait and only develop our sustainable fuel agenda. We also need to start working on the removal side, and that's why we are happy to be the first airline group, and especially Swiss, the first local airline also to partner with Climeworks in starting that and getting the train rolling. So is there any caveat? Of course it is, because we know we wanted to get the sign there is demand, and we wanted to show that growth can happen and needs to happen. Of course, we know that, or we are waiting for the market effects, that these signs of demand will then start normal market effects, and of course demand should lead to a growth in supply and help us to reduce prices. And that's also why we're happy that Climeworks announced the new technical solutions they have that hopefully then helps in a part of scaling in bringing the price down to new levels. So this is basically what aviation is all about. Thank you for listening. I guess lunch is next, so thanks for staying with me for so long. And any questions, happy to answer. Thank you finally to the Climeworks team for great cooperation so far, and from a personal side, I'm really happy that we get that train rolling, and also our second big challenge, that we are starting to work on it.
Thank you so much.
Sure.
There is one question.
Oh.
Recent analyses suggest that from an economic perspective, compensation via DAC with CS or DACCS might be more cost effective than the use of eSAFs, electrofuels. At the same time, it prolongs the use of fossil fuels and can create lock-ins. What is your perspective on this?
Well, it's a very good question. Thanks for that. And but I think the answer is pretty simple, because what I tried to show earlier is that we know where the levers are that we can basically pull, and we are developing all these levers, and we try to have an active role in developing it. But we are also very committed to the normal hierarchy. It was mentioned earlier or mentioned by the Oxford standards. We, of course, attain to this hierarchy of that reduction is first and removal is second. Giving all the uncertainty in that growth, I think one thing is also important, that we keep all those levers at hand and that we develop all of them to make sure that in the end we can meet that that target in 2050 of being net zero or carbon neutral. So I guess it's the clear point. Let's be open for technology, but of course attain to the hierarchy that we know.
Thank you.
Thank you.